Hello and thank you for subscribing to Infowars Tech. This is a channel where we explore new technologies like artificial intelligence, machine learning, big data, data analytics, and today we're going to look at Julia. Julia is an open source programming language and it's made available under the MIT license. Julia is designed for high performance, it's dynamically typed and feels like a scripting language. The Julia commands are case sensitive, and an important thing to note is that the index starts with 1 instead of the usual 0. If you're aspiring to be a data scientist or somebody who will work in the data analysis and data analytics field, you should look into Julia. It's becoming very popular. It's very fast, and it is designed to be able to manipulate data in a very powerful way. So we are going to take in today's video, we're just going to take a look at the mathematical operations, so using Julia as a calculator. But in subsequent videos I will be covering more elaborate and complex mathematical operations, strings, and the rest of the Julia language. So do stay tuned and do remember to hit the subscribe button. So let's get started. There are multiple ways to use Julia. What I'm going to demonstrate is two ways. One is to use the Julia CLI or command line interface, and the other way is to use Jupyter notebooks. Now Julia does not come with in Jupyter notebooks. We need to install that. I've covered that in a separate video, and I'm going to include a link for that here. But for now, let's get started, and I'll quickly show you how to launch the Julia CLI. It's easily available for Windows. You can download it, and as well as Linux and Unix systems. And but my video will be based on Julia running under Jupyter Notebook. So let's take a look here. I have already installed. You can see it's version 1.61, and this gives you a Julia command line, and you can run Julia commands here. So it's a nice tool to have to be able to quickly check your code. So let me go and launch my Jupyter here, Jupyter notebook, and you can see since I already have Julia installed, I can go into new and I can select Julia as well as Python 3, which comes bundled, but I have Julia 1.61 here, so I'm going to launch that. I'm going to give it a name, Introduction to Julia. Okay, so let's get as a basic example, let's check the version info. So version of this installation of Julia, and let's run that. So that's 1.6.1, which we had confirmed with the CLI as well. So let's get started with the mathematical operations. So Julia supports 4 basic number types. They are integers, floating point numbers, complex numbers, as well as rational numbers. So I'm going to cover rational numbers in the second video, but for now we'll basically be looking into integers and floating point numbers. So let's go with the basic operations like addition. So if I add two numbers, both are integers, I expect the result to be also an integer, so you get 5. If I change that to a floating point number like a 3.0, the result should be, so it automatically detects the type and gives you a floating point. So just by changing one of the numbers in the addition or subtraction, it will generate the result correctly to show you as a floating point. Let's look at subtraction or minus. So again, simply nothing special here, using Julia as a calculator. perhaps we have another number which is floating point. When you run that, it gives you this. We can check the type anytime, so type of, and you can say 20 minus 9.3, and when we run this, it should give us the type of this. So correctly it identifies that as float 64. And if we check for the first one, which is type of, let's say we're adding two numbers together and they're integers, let's see what, so it correctly identifies them as integer 64. So very handy way to check, but since it's dynamically typed, it can make a very good idea about the resulting type. So that's an advantage. It helps you write code faster. Let's look at multiplication. Again, these are very simple examples, but the reason I'm showing them here is if you're just getting started, maybe just familiarize yourself with Julia using these basic mathematical operations. Similarly, we have division, and that should give you the correct answer. Let's look at another option which is slightly different for Julia. So let's say I'm going to use something called inverse divide. So let's say x equals 5 here, y equals 7, and we are going to use something called, I'm just going to comment it out, so x. So basically what you're calculating is an inverse divide, and let's see how that works out. So if we remove the comment here and run this, let's see what what it's doing is actually inverse of x into y, so which is 7 divided by 5. So just by changing this symbol here, you do what is called an inverse divide. Now let's look at a slightly different calculation involving all of the addition and subtraction that we did earlier. So let's say I want to calculate the Fahrenheit of this temperature here, which is 22 degrees centigrade. So my formula is to convert between Fahrenheit and centigrade, so 9/5 into C, and I'm adding 32, so let's run that. So 71.6 degrees Fahrenheit. Very, as you can see, the syntax is very clean. It's very easy to write. We also support x raised to another power. So let's say x raised to y, and that should run. That's 5 raised to 7. It gives you the correct answer. We can also introduce a symbol called this stands for remainder. So when we run this, you should get the remainder for these two numbers. Let's look at some other options. So very interesting syntax here. If I'm doing 15 minus 9, some numbers, and this is actually an example of using PEMDAS, which is parenthesis, then exponents, multiplication or division, addition or subtraction. So that's what Julia also supports. So here I have two numbers, so 15 minus 9 in brackets divided by 3 comma 15 minus 9, and I'm putting them side by side just to show you when we execute this you get different results, because the parentheses are changing the priority of the operation. So when you run that, so you correctly get those numbers. But the interesting thing to notice that we put them side by side, separated by that comma, and it gives you two results side by side. So an excellent way to compare two different operations. Similarly, we can use a syntax like following. So I have maybe a bunch of numbers, and I can add them up all together, and it adds them up for me because of this unary number I have here. Similarly, for multiplication, I can change that to multiplication, and it'll multiply all these numbers that are inside those parentheses. Let's move ahead and look at some more functions. So let's look at as an example square root. So you already have that built in. Let's take a square root of 64 and run that. Gives you the correct answer. You can also always do a type check if we are unsure. Let's look at some other example. So let's say you also have a built-in cube root. So let's say 125, and that should give me the correct answer, 5, right? So it's also able to take a cube root, and that's also a built-in function. Let's do a division, and this will truncate towards 0. So the answer should be 2.5, but since we are truncating towards 0, it should give you 2. Let's take another look at what is called FLD. That's another built-in function. This is a floor division, and when we run this, it does a floor division. Let's look at another one, which is called CLD. This actually does an opposite of FLD, which is floor division. This does like a roundup. So let's run that, and because the answer is 2.5, it rounds it up to 3. Okay, we already looked at remainder. Let's look at mod, which is modulus. So as we know, modulus, it takes two numbers, and if I do 5 and 2 and run that, I get 1, which is the remainder, because 2 times 2, 4, and I get a remainder. But if I change this to, let's say, something that divides equally by 2, I should get a 0. So you get a modulus 0 because it divides completely. So another interesting functions which I haven't seen in some other languages, which is to be able to combine these. So I can do a divrem, which is a combination of division and remainder. So if I take the same two numbers, it'll print them side by side. So I get 2 and 1. So one for the division and the other for remainder. Let's look at another combination, which is fldmod. So this is floored division and modulus. So same numbers, and see what the result is. You can see it gives you again the right result. So very interesting way to combine these div and rem and fld and mod to get this answer. It also supports GCD, which is the greatest common divisor, which is a built-in as well. So let's take two numbers, 6 and 9, and if we run that, we get 3. Let's run. We also support LCM, which is largest common multiple. So if I run it on the same numbers, I get 18. So again, these are built-in functions which are very helpful in when we're doing that coding. Absolute. So let's take a negative number. When I run that, it should give me. Let's just change the sign. I can also look at some numbers in a list, and it should give me the max number for this. So it's able to identify the maximum number for in this list. Let's try another one, which is minmax. However, this uses 2, so we can just take 2 numbers, and when we run this, it will rearrange them in the format of minimum and maximum. So again, this is a combination of minimum and maximum. Let's look at some other basic functions like factorial. Again, if I give it 4 or some other number, it gives me the factorial for 4, which is 24, which is correct. And I can also, Julia also supports binomial. So let me choose 2 numbers, 5 and 4. So this is so many ways or to choose out of n items. So let's say so many number of ways to choose k out of n numbers. When I run that, this is used in permutations and combinations, so I get the correct answer, which is 5. So this was a quick tutorial to introduce mathematical functions which are in Julia. I could have run the same in this CLI for Julia, and as you can see, the syntax is very clean, and it supports a large number of mathematical functions that are built in, like binomial, minmax, LCM, GCD, and some unique ways of combining multiple functions to represent the output side by side. So I hope you enjoyed the video, and you're interested in learning more about Julia and the other functionalities. So stay tuned, and I will be publishing more more videos that show the power of Julia and how it is being used in mathematical computation and data analysis and analytics. Thank you for watching, and don't forget to hit the subscribe button.